Hackers and hackerettes, so welcome to a new video. In this video, we're going to be talking about SQL as fast as possible. Why is this important? Whether you're a developer or you're a cybersecurity student, or you're just here to learn something new, or you're just having fun, SQL is very important because it is the language you use to talk to databases. Now on the right here, I have my script. This is why I'm looking to the right, or at least to my right, to your left. And because I don't want to forget anything that I have planned to talk about in this video. I'll try to go as fast as possible. The very first thing you need is to have MySQL installed locally on your machine. I'm using a bundle development environment called Laragon, which works pretty well on Windows. You could use WAMP, XAMPP, or whatever else. All of them come with MySQL pre-installed. So you could just use Laragon as I'm using and then make sure MySQL is turned on. And now you do have the service running. Now we do know that MySQL runs on port 3306 by default, which is, we've already seen that in my SQL injection video, the lab that we've gone through together. If you have not watched that, I do recommend you watch it because we go over some security or MySQL from a security standpoint. Now, we don't care about the port in this scenario because by default, it is running on 3306, which is a default port. So we don't need to worry about it. Now, to connect to MySQL, I'm going to use my terminal right here, and then I'm going to type MySQL. It is a MySQL client or CLI, command line interface. I'm going to type TAQ for root, and that's all I need. So TAQ here stands for user. So I'm just logging into MySQL using the user root. By default, MySQL utility is going to assume that we're connecting to localhost, which we do have a service already running thanks to Laragon, and everything works just fine. So right now, we are in the MySQL connection. The very first command we could learn about is the show databases. So whenever we are in MySQL, we could just type show databases, and it's going to show all the databases that we have locally on our machine. The databases you probably have will be information schema, MySQL, and performance schema. These are default MySQL tables, databases. So don't worry about these. The other ones are systems that I worked on. Now, let's actually create a new database together. You can do that by using create database, and then I'm just going to type 47. End our query with a semicolon, because that's how we end every single SQL statement. Boom. One query or one row affected, query okay. Now if I do show databases again, we are gonna get 47 as the database right here. To use this database, I'm gonna type the keyword use and then 47 semicolon, and then it says database changed. Beautiful. Since now we're using a database, I can type show tables, which shows an empty set because we did not create any tables. Now if you don't know what a database is, essentially a database is a collection of tables. Each table consists of columns and rows. So it is kind of like a grid or an Excel sheet, but it is much more powerful because you can do a lot of interesting stuff with that data using the SQL language that we are learning right now. Beautiful. Now, I will not spend the entire tutorial in the terminal. I actually have a very cool program or application that I'm using, which is called I forgot its name. Table Plus. Yes, this is what it's called. So Table Plus here is a client for MySQL. I actually used it to connect to localhost, and then I can press the databases here, which shows me my database that I just created. Wonderful. I can click open, and then from here I could actually see all the tables and all the data that I have. We do not have a table yet. So this is what the very first thing we're going to do is we're going to type new, and then we're going to choose table. Now, this is much easier to deal with the GUI instead of dealing with the terminal to just create tables and do all of that stuff. But we'll still learn SQL directly inside Table Plus. So what we're going to do here, let's make this a bit bigger for the recording. So the column name here and also our table name. Whoops. Our table name, I'm just going to call it users. And then we are going to leave everything as is. I do want an ID. And then I'm going to type the column name. And the next thing will probably be like email. That's it. Can only be one auto column, and it must be defined as a key. I believe we should talk about what is an auto column right now. An auto column is essentially a column that has the word serial right here. So serial or auto increment, it essentially means that it is gonna auto increment. Let's change these to 1s and 2s as well, because we want this position 1 and position 2. Now the data type here, instead of serial, I'm gonna choose varchar instead of serial for the name, and then varchar for the email. Now what is this going to do is that this is the type of the data that we are assigning to this column. So we are telling MySQL that the column name, its values should only be variable character, which is a string in like programming, if you know data types and programming. Now we do have a lot of data types, but we will not be going through all of them. The most important ones that you need to understand is probably big int, or like big integer, like big numbers. You could learn about doubles and floats, which are essentially the same, but double has more precision. And then you have int, which is like a regular number, and varchar, which is the most important. You could also learn about boolean, which is true or false, which we can talk about in a separate video. If this video is not enough to learn the basics, let me know in the comments, and then we can create like a follow-up. Now I'm gonna click Control S to save my changes, and now I do have a table called users. If I open that, I click on data, and then I can see immediately that we have ID, name, and email. The way to do this is that I could show you here how we can create a table using SQL or raw SQL. We can essentially say create table and then give the table a name. We call it users, just like our table here. Now we're going to use ID, type of int, and then auto increment. Auto increment means it is going to be used, or is going to automatically increment the more you enter rows into the users table. So you don't have to like check what is the list ID that I put in there. Oh, it's 1, so that means ID needs to be 2, which is 1 plus 1, and so on. No, you don't need to worry about that. The database actually takes care of it. Next, you have your name as varchar, email as varchar. There are some extra columns here, like age, which is an integer, and then created at, which is a date time. Now, the default here means, what is the default value for this? If I don't enter a value for it, the default should be current timestamp, which means if I don't give you a specific value, then just default to the current time. You also have flags here like unique and not null. Not null is like a constraint, which means that the email, every row must have an email, and you cannot enter a new row without entering its email. Same for name. But we don't have these restrictions on our table. So what I'm going to do, I'm actually going to delete the table that we created together. And then I'm going to create this table right here. You can, by the way, just make your cursor stand at the end of any query. Click Control and Enter in order to run the current, or you can just use run current from here, and it's going to run this SQL query against your current database. So you can see here there is no tables. That's because we did not refresh. I can press Control R to do a refresh, and then I see users pop up right here. Perfect. If I open users now, I can see we have name, email, and then age, and then created at. Perfect. So now we know roughly how to create tables and different types of data types. Now let's get into actually inserting data into our database. So to insert data, it is actually super simple. You need to use the insert keyword. Now you could type everything in lowercase, but it has just become like a standard to use all uppercase for MySQL or SQL like language. So just write everything in uppercase, because that's probably how you'll encounter it all across like your career. But if you type it in lowercase, nobody's gonna like it's not wrong per se. So insert into, and then we type the table name, users, and then in between parentheses here we could define the columns that we want to insert into. So right now I'm going to add a new user, name, email, and age. These are the columns that I need to worry about in order to enter a new row. ID, I don't need to care about because it is auto incrementing, and created at has a default value of current timestamp, so I do not need to worry about it. So we need to worry about name, email, and age. Now I want you to know or understand that it does not have to be in the same order that they appear in here, but whatever order you enter here, you must match after the values keyword. So in the values here, that means insert into the table named users these columns, the values, and then you just give it the value. So for the name, I'm just going to enter 47. For the email, I'm just going to enter my email at email.com. And then for the age, I'm just going to enter like 20. Then I'm going to click Control Enter. You can see here our row 1 is okay, and then rows or 1 row is affected. If I go back to my users and then I give it a refresh, boom, we do get our row right here. And you can see how now it is much better than doing it in the terminal, because in the terminal it's going to be a little bit messy. So that's why I wanted to show things like clearly using a visual and a GUI program. So we do have ID 1, name 47, email, my email, and then age. Let's enter another one so we have like multiple values to deal with. I'm just going to enter Alice, and then Alice at email.com, and Alice is 22. Control Enter to execute that. Give it a refresh right here. We get Alice. One more. John Doe. John at email, and John is a boomer. He's 32. Refresh or Control R to refresh without like right clicking, and then we get all of these 3 data that we have. Notice something, that the ID is auto incrementing starting from 1, not from 0, by the way. If you know any programming, you know most programming languages are 0 indexed. MySQL starts from 1, which makes sense. ID 0 does not really make that much sense. And then the created at, we did not explicitly set it here, but the created at has been defaulted to the current timestamp. If you click on the structure tab here, you're going to see that, never mind about the indexes for now, but you can see that the created at is of data type datetime, and then the default is current timestamp. Wonderful. Now, since we know how to insert data, let's actually learn how to fetch data. To do that, we use what is known as select. Now, the most basic form of a select is a select star from, and then the table name. So select star from users. If I execute this, you can see that we actually get the entire database back, or the entire table back. So all the values that exist in our table just come from select star from users. So that means just give me everything, no filters whatsoever. Cool. Now let's learn about filters, since I already talked about filters. Before that, the star here actually means give me all the columns in the table users, or from the table users. So select star, if you have seen my SQL injection video, you will know that we actually use something similar to this, but I digress. So going back, we can actually specify the columns that we need to select. So for example, I only need to select the name and the age. So I just want to select everybody and their age from my users table. What I could do, I could delete the star and then type name, comma, age. I could also add a space or without a space, it does not matter. But there's a comma, and then I Control Enter. And there we go. I basically specified specific columns that I want to select from my users table. So 47, Alice John Doe as the name, and then their ages right there. Beautiful. Now let's actually bring it back to select star, and then let's talk about filters. Now to do filters, we need to add the where keyword. So select star from users where, and then we could type a column name. So for example, I could type where ID and then equals and then 1. So that means give me everything from the users table where the ID of that row is 1. And there we go, we get 47. If I change this to 2, what am I gonna get? Good job, we're gonna get Alice. Of course, I can change it to 3. I'm going to get John Doe. Now, is it necessary that we always get a 1 row back? Of course not. What I could do is I can say where ID is greater than 1. Can you guess how many rows are going to come back? 2. Alice and John Doe. Perfection. Because these IDs are 2 and 3 and they are greater than 1. Because ID here is actually an integer, it is a number, the database knows how to do comparisons between them. Beautiful, beautiful. We can also do greater than or equal to 1. We can also make less than 1, which are going to get nothing because we do not have an ID that is smaller than 1. But we could do smaller than 2, which is going to give me how many rows? Exactly, 1 row with 47. Beautiful. That's because there's only one row that has an ID that is less than 2. And we could just go back to our equal, and now you understand how we can do like basically a small set of comparisons in integers. Awesome. Now let's talk about something else. I'm gonna make ID equals 1, or ID is greater than 1, and then I want to add another filter. So for example, I want to select users that have an ID greater than 1, but I want their age to also be greater than 20. Okay, that's good. So where ID equals 1 and, which is a keyword, age is greater than 20. Boom, we get Alice and we get John Doe. Why? Because Alice's ID is 2 and her age is 22. John's ID is 3 and then their age is 32. Both conditions or both values match the conditions right here. We can even take this further. We could only select their name. So who from my users have an ID greater than 1 and age greater than 20? It is Alice and John Doe. Beautiful. Now I'm going to teach you something cool. Let's leave this here and then work on a new query. I want you to imagine we are in a website, and then we have a list of our users, and there's a search bar. Okay. So in the search bar, we could just search by username. Okay. How can we do a search by username or by like name in our database? So essentially, we're just gonna select probably just everything from users, okay, where we are searching by the name. So where name, and then look at this, like, and then we add a string. Of course, every query ends in a semicolon. But then like a string, and then look at this, I'm gonna put a % before and after, and then in here I'm just gonna type John. Now what is this doing is essentially we are telling the database, go to the users table, to the name column, and then look for anything in the name column where it has a value that is like John, but there could be anything before it and there could be anything after it. This is essentially like a wildcard select. Doing this is gonna give me John Doe, but how did that work? The name is John Doe, not John, but it's because we're using a like statement. Now I want you to see what happens now. If I delete the last %, I get nothing back. Why is that? I give you a few seconds to guess, but because like I explained, the % right here is essentially a wildcard holder. So that means what our current query is searching is everything before John, but there cannot be anything after John. In our John Doe, we have the name John and then a space and then Doe. So this does not match this. In fact, this matches this. If I run this now, we actually get John Doe back. Okay? Now, we can use this with any string that we'd like. We can even search by email. So where email, like anything at email. So we want to grab everybody that has an at email or maybe at Gmail. So we want to see from our list of users, everybody that is using a gmail.com domain. We can do it like that. Okay? A more efficient way is to remove this because we know at gmail.com is the end of the string that we are looking for. So this is a bit better or a bit more efficient. Okay? Now we do not have anybody using Gmail on our data, but we at email.com, everybody's using at email.com. I hope you can see now how flexible this is. Okay? Now we did come to a really cool development feature right here. We said that our search could either be by name or by email. Does that mean I need two separate queries in order to actually achieve this? So maybe select star from users where email like that, and then where name like that, and then I could check like which one returns data. You could do it that way, but that's not really the best way to do it. The best way to do it is to actually do the following. Select star from users where, and then we can open parentheses here and then close it. go in a new line. You don't have to use the same formatting. MySQL and SQL does not care about formatting and white space at all. You can go crazy, but this is going to make things clearer for you. What I'm going to do here is I'm going to write select star from users where email and then like exactly how I did it before. So let's say that the user inputs like John, and then we want to search for users that have an email or a name that is like John, because we do not know what they entered. Now, if you don't know, in MySQL, a double dash here means a comment. You can also comment by using a hash symbol, but I guess it's not shown in Table Plus. So we'll be using this double dashes because it turns things green, and now you know that this is a comment. This is actually like it will not be executed. So select star from email like John, the exact same way that we wrote it. So far so good. Or name like John. Now you can see what's going to happen here. Now where, and then we have parentheses, email like John or name like John. Now, because one of these conditions, at least one of these conditions is true, then you know that you are going to get John back in the search criteria. Now, I could do where email like, for example, test or name like John, I will still get John back. That's because one of these match. Now, I want you to notice something as well. Let's type the name here like test. We still get John, even though we match the email with a capital J, but then John here has a lowercase j. So by default, the like, at least in MySQL, because it could be different in places like Postgres, for example. So this is like something that you'll actually need to figure out for yourself, depending on the database engine that you're dealing with. Since we're dealing with MySQL here, the like is by default case insensitive. So searching for this actually yields results for lowercase j as well. But this could be different depending on the database engine that you're using. So are these parentheses important? Actually, in this case, no, it's not. So I could delete this, and we're going to get the exact same results back. Why did I add them? One, because it is a good practice to add them, because now you know that this logic is grouped together. Next is that if we have more conditions which we could add, and ID is greater than 2, for example. Now you can see what's going on here. We need to one of these be true, but alongside one of these, we also want the ID to be greater than 2. If I run this, if I run this, I actually get John back. Now I want you to imagine if I have ID is greater than 3, I get nothing because I do not have that in my database, or in my table at least. So now you understand the importance of parentheses. Now if I delete these parentheses, things are going to go wild. I'm actually going to leave that to you to do that and test what's going to happen. Okay? Okay, let's talk about, so now we understand selects. Let's talk about something cool, which is ordering. Now I want you to select star from users. Now I will not be just typing everything in capital all the time. I will just be casually just writing lower, like using lowercase here, so don't get mad from me. But essentially both are the same. It's just what the kind of the standard is, but I don't really care much. All right. So let's talk about ordering. So you can see here, maybe we want to select a list of users ordered by their name. What we could do is select star from users, and then literally I could just say order by name, and that's it. Literally that's it. Now we can see that Alice, 47, and then John are ordered alphabetically, right? We can also order by age, which is going to order by age by default, it's ascending. So the lowest first and then the highest. You can reverse that by typing the word disk, or it's short for descending, by or after the order by. So now it reads like really well. Select everything. So I want you to just substitute the word star or the symbol asterisk or star with the word everything. So select everything or all columns. All columns is more accurate. So select all columns from users, order by age descending. Like it reads just like English, which is beautiful. It is truly magnificent. Once you get the hang of it, you do not even need to memorize a lot of these things. You maybe just need to memorize that you cannot say, for example, select star order by age descending from users. This is gonna cause a SQL syntax error. So you need to just remember like the orders, which makes sense. Like select star from where, from users, order by what age, and then the type of the order. You can type ASC here as well, which is ascending, but it is already inferred, like it is a default value. So you will probably only need to write descending if you want in descending order, which is pretty cool. Now we talked about all of this. Let's talk really quick about updating. Updating is super simple. So you could type update. Now, before I get into this, you need to be super extra duper careful here. Updating is destructible, meaning that if you update a value, it is being updated in the database, and this could cause massive problems if you update the incorrect data. And I'm going to show you why. Let's say that we discovered a problem in our database, and that 47's age is actually not 20, but it is actually 47. So we can, how do we fix this? Now, we can simply just say update users, and then what are we updating on users? We're gonna set age equals 47, but then I give you a hint there. I said only the user 47 should have their age updated to 47. If I execute this query like that, I want you to see what happens. 3 rows affected. That means it updated every single row in my database. If I select star, everybody has age 47. You can now see how broken this is and how you can so simply just mess up your data. If this is running on like live data and stuff like that, you need to be super duper careful when you're running updates or deletes. So the same thing goes for deletes. So right now, let's fix our data. So we want to update the user. Set age equals 47, but our 47's user is already age 47. So maybe we could update another guy. So let's bring back Alice to like 23. Where you can use where statements with the update, and this is how you filter that I only want to update this specific row. The easy way we could do is just say name and then equals Alice, like that. Or the easier way would be just using their ID. If we know their ID, sure. If we don't, then we could use like their name. So let's maybe update our John Doe to 32, I think it was. And then we could use ID here. ID equals 3 for John. Run that and then run select star, and boom. Now we have the correct ages kinda set to our users. Okay. Since we talked about update, let's talk about deletes. So delete is the same as update, takes the exact same thing, but instead of delete users, we delete from users. And then we add a where statement. Now delete is used to delete rows, of course, so you don't need to specify like columns or anything, but you need to specify your filters. Now if I say delete from users, you can guess what happens. It's gonna nuke the entire table. So it's gonna delete every single row from the table. This is why you should just add a where statement. So delete from users where, and let's just add, let's delete John Doe. So ID equals 3. Boom, 1 row is affected. Select star from users, order by age descending. Now I want to teach you something that most of the tutorials on beginner tutorials do not teach, but I do recommend. It is very, very important to teach. Let's talk about transactions. I did mention how dangerous it is to run updates and to run deletes because if you forget the filter or even use the wrong filter. So I want you to imagine that instead of ID equals 3, we said ID greater than 1. And then it's going to delete every single row that has an ID greater than 1. Now this is of course pretty dangerous. How we can actually protect against this? We could use something known as a transaction. A transaction actually, what is it going to do is that I just need to check the correct syntax for it in MySQL. It's been so long to use in MySQL. So MySQL transaction syntax. What is a transaction? I'll show you. So it is start transaction actually, not transaction, sorry. So start transaction, and then it says query 1 okay. Now everything that I do, so for example, I could delete users where ID equals 2 right now. You can see that we already deleted our user. So if I try to choose everything, it's gone. So what did the transaction do? Now, what I could do is I could actually do what is known a rollback. Boom. When I do a rollback, I could actually select star and I get Alice back. Now you can see the power of this, because since I already started a transaction, I could roll back whenever I wanted to after confirming that my so I could use rollback if I confirm that my query was incorrect and I do not lose any data. So a transaction is like a temporary state where your queries take effect, but it is not fully committed yet. Now watch this word, commit. This is actually the word that we need to use if we want to commit our transaction. So that means my query was good to go, commit that. Let's get an example right here. I'm gonna add back John Doe. And then I'm gonna select star, and then I see John Doe back, which is cool. Now what I'm gonna do is I want to delete John Doe now. ID is 4 for John. So what I'm gonna do is I'm gonna start a transaction just to be safe, and then I'm gonna delete user 4. Okay, so now the user is deleted. I'm gonna select, okay, it looks like we deleted John Doe. Nothing else of our data was affected. Now what I could do is type the word commit, boom, query 1 okay. Now I could just select star and John Doe is gone forever. I cannot roll back. So if I do roll back and then select star, I do not see John Doe back. Why? Because we already deleted it. Already like committed our transaction. So start transaction, do your dangerous stuff, and then you have rollback and commit to either rollback or commit your transactions. Always start transactions before you do deletes or updates. Even when you do inserts as well. You could very well just insert a lot of data that you do not need. So it is just a best practice to start transactions whenever you're working with data that is scary. Okay? Most of the beginner tutorials do not get into the transactions. Please learn them, use them. The earlier you learn about them and you start using them, the more like a habit it becomes, and it just becomes second nature that whenever you're doing something dangerous, you're just starting transactions and so on. Now, of course, I'm not gonna be using transactions in this database. I do not completely care. There is no data here that I care about. So yeah, we'll not be using transactions, but they are very important for you to understand. Now, one more thing that I want to talk about real quick is that multiple inserts or like limits actually. So John 1 and then 2 and then 3. Okay. So looking at this, if we're going to select star, we can see multiple John Does here. Now, let's say, just for the sake of the argument, there is a feature on our website or our system that is using this database that you can search, but you only want to show the very first search results. So now, if I bring this back, remove the ID, and then I want to search for everybody that has either an email or name, that is John. And then we get all of these results back. But I want to limit the results to only the very first result. This is how the feature that works. I just want it to work that way. We can do that by doing a limit and then 1. So we can just add however many rows we want to limit. And we can just do that by adding the keyword limit. So the word or the keyword limit comes after the keyword order by. So I could order by name, but in this case it does not make sense because it is limited by 1. So ordering by name does not make sense. But maybe we could order by ID descending, which means I want to show the latest inserted row that matches this criteria. And we can do that by ordering by ID descending and then limiting one. You can see the structure here. So we're doing the select with filtering, ordering by ID descending, so the from the highest to the lowest, and then we're only limiting one, which we're choosing the first row, which gives us the ID 8 with John Doe 3. The name John Doe 3. If I go back to my database, you can see that this is the latest John Doe that we have, and it is the highest ID that we have. Instead of ordering by ID, we could also order by created at, which is the date. And then it is going to give us the exact same results, because you can actually order by dates. And this is the power of date times fields in databases. You can do a lot of things on dates and times, but we're not going to get too much into it. Okay. And the last thing that I want to talk about really is a few keywords that are scary. One of them is truncate. Truncate users means just delete everything from users. It is similar to delete star. The only difference is that delete star does not reset the ID counter, but truncate does. So now if I enter, or if I create a new user in my users database, and I actually go check the data, you can see that the ID starts from 1. But if I do a delete from users, just like that, to delete everything, so you're going to see that everything has been deleted. But if I enter a new user again, it starts with ID 2. This is a difference between delete from users and then truncate users. Okay. The last thing, which is the most destructive thing that we're going to talk about, is the drop table. I don't need to explain what this does, of course. It just deletes your table. And this is it. This is all I want to talk about in this intro tutorial for SQL. I tried to keep it under 20 minutes, but we are already in 37 minutes. I guess there is a lot more to even talk about right now, which, for example, subqueries, and then we could have joins as well. Joins is actually more important. We could also talk about indexes. But I'm going to keep this for a more advanced tutorial. Let me know how you find this video, if you learned anything, if you find it useful. My channel is still a baby, and I'm trying to build a channel that gives back to the community. I learn from the community for free. I learn from YouTube videos. And this is just me trying to give back to the community. So let me know in the comments if you find these videos helpful. Give me a like, give me a subscribe, give me some constructive criticism. Tell me you don't like me, you don't like my voice, you don't like how I look. I don't care. Just be constructive about it and tell me what I can do different to make these videos better for you. Before I end this video, please use transactions. Start transaction, do your destructive thing, and either commit or roll back depending on what you want to do. This could have saved me countless hours of just scrapping through backups and trying to restore the most recent backup because of a stupid mistake that I was using a different program, and the program executed SQL only the selected part from the query. So even though I have this selected, but the query ends here, it only did that. So you can see how dangerous this could be and how much time that it wasted from my life because I was stupid to not use a transaction. Please do not do the same mistake. Please use transactions for any of your, I would argue you can use it before doing any query on the database. But if you're doing selects, that's fine. You don't need to use that. But if you're doing updates or deletes, please use transactions. You will thank me later. Or I wish you never thank me because you're never going to get into trouble. But if you do not use transactions and then you make a mistake, which you are bound to do, we are all human, you will be remembering this. So thank you for watching, and let me know in the comments if you want to see a more advanced tutorial of this. And yeah, I will see you in another video. See ya.